Second, from alkyl halides. By using a dry silver oxide. Symmetrical ethers can be prepared from haloalkanes by reacting with dry silver oxide. Moist silver oxide is same as silver hydroxide. Moist silver oxide react with haloalkanes to form alcohols. Here dry silver oxide is used. Symmetrical ethers are obtained. If a mixture of two different haloalkanes is treated with dry silver oxide, a mixture of three different ethers are obtained. As in a mixed Wurtz reaction, three types of ethers are obtained. ROR, RO, R dash, R dash O, R dash. Hence, this method is not suitable for the preparation of unsymmetrical ethers. In other words, only symmetrical ethers can be prepared by this method. As an example, ethyl iodide on treating with dry silver oxide gives ethoxyethane or diethyl ether. These two iodine atoms are removed as silver iodide. By Williamson's ether synthesis, both symmetrical and unsymmetrical ethers can be prepared from alkyl halides by Williamson's ether synthesis. It is a nucleophilic substitution reaction following SN2 mechanism. Alkyl halide is treated with sodium or potassium alkoxide or phenoxide. The alkoxide or phenoxide is a nucleophile. It displaces a halogen atom from alkyl halide to form ether. It is a nucleophilic substitution reaction following SN2 mechanism. Hence, this reaction is given by methyl halides, primary alkyl halides, and a few secondary alkyl halides. Tertiary alkyl halides do not give this reaction. Due to partial double bond character of carbon-halogen bond in haloarenes. Haloarenes or aryl halides also do not give this reaction. As an example, methyl bromide on treating with sodium methoxide gives dimethyl ether. It is a symmetrical ether. Methyl bromide on treating with sodium ethoxide gives methyl ethyl ether. It is an unsymmetrical ether. Methyl ethyl ether can also be prepared from ethyl bromide by treating with sodium methoxide. Since methyl halides are most reactive towards SN2 reaction. First set of reagents are most suitable to synthesize methyl ethyl ether, that is methyl bromide and sodium ethoxide. Tertiary alkyl halides like tertiary butyl chloride do not give this reaction. In the case of tertiary alkyl halide, mechanism of nucleophile substitution reaction is SN1. That is, it involves a carbocation intermediate. Since sodium methoxide is a strong base, carbocation is readily deprotonated to form alkene. In other words, reaction between tertiary butyl chloride and sodium methoxide gives isobutylene and not tertiary butyl methyl ether. In order to prepare tertiary butyl methyl ether by Williamson synthesis, the correct choice of reagents are methyl halide and sodium tertiary butoxide. In the case of methyl halide, only SN2 mechanism take place. That is, a tertiary butoxide ion make a bond with a carbon atom of a carbon halogen bond. Hence, good yield of ether is obtained. That is, in order to prepare tertiary butyl methyl ether by Williamson's method, the reagents should be methyl halide and sodium or potassium tertiary butoxide. Tertiary butyl halide and sodium methoxide do not give the ether because the carbocation intermediate deprotonate by the action of a strong base, methoxide ion. Hence the product will be alkene, that is elimination product. Ethers having a two tertiary alkyl group like ditertiary butyl ether cannot be prepared by Williamson's method. In order to prepare ditertiary butyl ether by Williamson's method, the alkyl halide should be tertiary butyl halide. In the case of tertiary butyl halide, mechanism involves carbocation intermediate and hence elimination reaction take place. In other words, ditertiary butyl ether cannot be prepared by Williamson's method. Aryl halides like chlorobenzene do not give this reaction. That is, anisole cannot be prepared from chlorobenzene by reacting with sodium methoxide. It is due to partial double bond character of a carbon-chlorine bond. Anisole can be prepared by Williamson's method. The correct choice of reagents are methyl halide and sodium phenoxide. Sodium phenoxide react with methyl chloride to form anisole. So ethers like diphenyl ether cannot be prepared by Williamson's synthesis. In order to prepare diphenyl ether, chlorobenzene and sodium phenoxide should be taken. This reaction will not take place due to partial double bond character of a carbon-chlorine bond. So, ethers having two tertiary alkyl groups or two aryl groups cannot be prepared by Williamson's method. It is a drawback of Williamson's ether synthesis or limitation of Williamson's ether synthesis. The advantage of Williamson's ether synthesis is that both symmetrical and unsymmetrical ethers can be prepared. Aryl halides having strong electron withdrawing groups react with sodium alkoxide or potassium alkoxide to form aryl alkyl ether. For example, 2,4-dinitrochlorobenzene or 2,4-dinitrofluorobenzene react with sodium methoxide to form an ether. (2,4-dinitro)anisole is obtained. SN-AR reactions, that is aromatic nucleophile substitution reactions, can take place if aryl halide have electron withdrawing groups like NO2 at ortho and para position. Mechanism of the reaction involves a carbanion intermediate. Nitro group stabilizes the intermediate and hence SN-AR reaction take place. It is an example for a Williamson's ether synthesis that following SN-AR mechanism. It has been discussed along with the chemical properties of aryl halides.